Good evening, everybody. I am Gayatri, Assistant Professor working at Hindustan College of Engineering and Technology. In this PPT, we are going to see about standard signals, types of standard signals, and finally, we are going to see about each standard signal with diagrammatic representation. Standard signals, otherwise call it as a elementary signal. Here, these are the standard signals or elementary signal. The first is step signal, ramp signal, impulse signal, parabolic signal. These are called as a test signal. And next, sinusoidal and exponential signal, signal, rectangular signal, signum signal, and finally triangular signal. These are called as a input signal for process. It can be represented either in a continuous time and discrete time. The first signal is about step signal. Here we represented in both continuous time signal and discrete time signal. The continuous time signal we represented as u of t, and in discrete time signal we represented as u of n, which represents the unit step signal, the unit which represents the 1. So u of t equal to 1 for t greater than or equal to 0. Otherwise, it will be 0 for t less than 0. See the diagram. Here, it will be 1. The signal will be 1 for t greater than or equal to 0. If t less than 0, the unit step signal becomes 0. The unit which represents the 1. Otherwise, we represented as a. That is x of t equal to a for t greater than or equal to 0, and it will be 0 for t less than 0. Likewise for discrete time signal. And the application is, it can be used in a communication applications and DC generator. The next signal is a ramp signal. It can be represented in both continuous time signal and discrete time signal. Here, r of t, which is equal to t for t greater than or equal to 0. For t less than 0, it will be 0. So the signal is when t equal to 1, it will be the signal will be 1. So according to the t value, the signal will be present. The application is current and voltage relation circuits. The representation in continuous time signal, it will be r of t, and for discrete time signal, it represented as r. The next standard signal is a pulse signal. Otherwise call it as a rectangular pulse function. Here we can represent it in discrete time signal and continuous time signal. So see the diagram. For the time period t1 up to t2, the signal is present as A. Otherwise, the signal will be 0. If it is a unit pulse signal, it can be presented from minus 1 by 2 to plus 1 by 2. The signal will be 1. The next is impulse signal. It also represented in both continuous time signal and discrete time signal. See the diagram. The del of t, which is equal to 0 for t not equal to 0. The del of t will be 1 for t equal to 0. When t equal to 0, the signal will be 1. Otherwise, it will be 0. So, the application is a ECG function. The next signal is a sinusoidal signal. It is also represented in both continuous time signal and discrete time signal. And also this signal will be represented in both sine and cos. If the signal starts from 0 point, then it will be represented in the sine form. If the signal is started from 1, then it can be represented in the cos. So see the formula, x of t equal to a sine omega t plus pi. The pi which represents the phase angle and t which represents the time period in seconds and a which represents the amplitude and omega which represents the angular frequency. And application of sinusoidal signal, that is any sound signal and light signal. The next standard signal is the exponential signal. So the representation of exponential signal is x of t equal to a e power s t. The s which represents the complex variable. So the s is represented as sigma plus j omega. And a is an amplitude. The next is the exponential signal can be represented in two forms, that is complex exponential signal and real exponential signal. The first we are going to see about complex exponential signal. Here we already seen that s equal to sigma plus j omega. If the sigma is positive, then it is exponentially growing signal. If sigma is negative, then it is exponentially decaying signal. For that we have a formula, that is x of t equal to a e power sigma t omega t plus j sine omega t. According to the sigma, either it can be a growing exponential signal or decaying exponential signal. The next is a real exponential signal. Here this omega value will be 0. So x of t equal to a e power sigma t. The omega which becomes 0. Depending upon the value of sigma, we get the DC signal or growing exponential signal or decaying exponential signal. The next standard signal is a parabolic signal. The representation of parabolic signal either as a p of t, which is in a continuous time signal, and p of n, which is in a discrete time signal. So this is the representation of parabolic signal. See the diagram, and here the formula is x of t equal to a t square by 2 for t greater than or equal to 0. For t less than 0, it will be 0. And application is by response to acceleration. The next signal is a sync signal. The representation of sync signal is a sync of t. It can be represented in both continuous time signal and discrete time signal. See the diagram. The sync signal is nothing but sine cardinal function, and it can be used in a digital signal processing and information theory. The next signal is a signum signal. It can be represented in both continuous time signal and discrete time signal. That is, for t greater than 0, it will be 1. For t less than 0, it will be -1. And it can be used in a communication. And the last standard signal is a triangular signal. It can be represented as tri of t. It can be represented in both continuous time signal and discrete time signal. Here the formula is x of t equal to 1 minus modulus of t by a for modulus of t less than or equal to a. And it can be used in analog to digital conversion circuits. That's all about standard signals. Thank you.